Students, we will discuss the structure of the carbonyl group in aldehydes and ketones. Both aldehydes, ketones have carbonyl group, that is C double bond O, right? And the carbon atom in the carbonyl group is sp2 hybridized. It has 3 sp2 hybrid orbitals which forms the sigma bond, one with the alkyl group, other with the hydrogen atom, and the next with the oxygen atom in aldehyde, whereas in ketones both alkyl group will be bonding to the carbon through sigma bond, and the another sp2 hybrid orbital will be forming the sigma bond with oxygen atom in case of ketones. So the carbon atom of the carbonyl group, so here we have, this is the carbon of carbonyl group. It undergoes, students, sp2 hybridization and have 3 sp2 hybrid orbitals. So this is sp2, this is sp2, right? Now this sp2 hybrid orbital will undergo overlapping with the sp2 hybridization, sp2 hybridized oxygen atom, right, and will form a sigma bond, right? And here also, if this is with the hydrogen atom, 1s of hydrogen, right, and this is with the carbon atom, right? It is also with the alkyl group, you can say here. This is of the carbon atom, right? It will be for the structure RCHO, right? Now students, the angle between the sp2 hybrid orbitals, all the 3 of the sp2 hybrid orbitals, student, it is 120 degree and it has got the planar structure. All these orbitals are on a plane, they are having a planar geometry. Now student, one of the orbital, p orbital of carbon, it remains unhybridized. It will undergo the lateral overlapping with the unhybridized pp orbital of the oxygen, and a pi bond will be formed. So here we can see that the carbonyl group has got 3 sigma bond and has 1 pi bond, right? And the bond in the student, it is how much? It is 120 degree. The oxygen definitely will have 2 lone pair on it, right? Now students, let us compare the nature of the C double bond O with C double bond C. Let's first see the similarity between these bonds. The first similarity, student, is that in both carbonyl C double bond O and the alkene, that is C double bond C, both undergoes sp2 hybridization. Second, student, is that both have the planar structure. And the next one is that both undergo addition reaction so that the unsaturation gets converted into saturation, or we can say that they get saturated. Right? Now, next come the differences between the 2 types of bonds, C double bond O and C double bond C. Student, the first difference is that in carbonyl we have more electronegative oxygen atom. You can see here double bond O, right? And due to resonance, student, it gains the polar nature. So we can say that C double bond O is polar in nature due to resonance. Second is, what student is going to be the second difference? Second is the addition reaction, definitely both of them show the addition reaction, but the carbonyl C double bond O, it shows the nucleophilic addition reaction, whereas C double bond C, it is going to show electrophilic addition reaction, right? So here we find that the alkene C double bond C, it will undergo electrophilic addition reaction, and C double bond O, it is going to show nucleophilic addition reaction. These are the main point of difference between the two. Right? Now student, here I have used the word that the carbonyl CO, it gets a polar nature due to the resonance. So if I show it in this way, double bond O. So here we will get, it is in this way, this is O negative and the carbon is getting a positive charge. Now these two are the resonating structure of one another. A and B, these are the resonating structure of one another. Right? So here we have discussed the structure of carbonyl group. Next student, we will discuss the preparation of aldehydes and ketones. Okay, now we are discussing the preparations of aldehyde and ketones. If we have to prepare both aldehyde and ketone students, we can use alcohol. This we have discussed in alcohol unit as the property of the alcohol. You know that alcohol undergoes oxidation in presence of acidified potassium dichromate or alkaline KMnO4, and it gets converted into the aldehyde if it is a primary alcohol, right? And if we don't stop the oxidation at this stage, at the aldehyde stage, then it will form the respective carboxylic acid, right? So from alcohol student, we can obtain either through the oxidation, and if we are using student, these reactions we have discussed in the alcohol units, right? So I am not writing the reactions again here. You can just get it. I am just telling only the process here. So if the oxidation is carried and we have primary alcohol student, that time to get the product stopped at aldehyde, we will add ECC or we can add chromic trioxide, right? And student, if it is a secondary alcohol student, that time the same oxidizing agent we will get the product form is ketone, right? Similarly student, we can get the aldehyde and ketones, right, from the alcohol again by the catalytic dehydrogenation. So if it is primary alcohol student, that time at copper at 573 Kelvin, you can use any of the primary alcohol, and when the dehydrogenation takes place in copper, in presence of copper heated at 573 Kelvin, students, we will get RCHO, that is the aldehyde, and if we have used secondary alcohol, same reaction condition, we will get the ketone. So students, here we are discussing the reaction preparation where both aldehydes and ketones will be formed. Now students, next is the ozonolysis of alkene. This too we have discussed though in previous year, that is class 11th, in the heading of properties of the alkenes, chemical properties. But here I am again revising it up here. So we are taking an alkene here, RCHO. You can show, you can take anyone instead of R, you can place here CH3 or C2H5, right, or any other alkyl group. We will get it reacted with ozone, O3, and an ozonoid is formed across the double bond. This one C double bond is going to open up, right, and this ozonoid will form, which when undergoes zinc distillation in presence of zinc and water, this ozonoid will undergo the splitting in this way and we will get RCHO and again RCHO here. We are getting aldehyde. And if we are in this way, if we have across the unsaturation student, if all the groups, alkyl groups are there, if there is no hydrogen atom, students, that time it is in this way. So what we will get here is, so here so we are having this R group. Now this is there. Now here when we are using zinc, we are following the zinc distillation. We will get a ketone form. Now depending upon whether the alkyl groups are same or different, the nature of keton is going to be different, or we will get same or different ketones, right? And so if across the unsaturation, if a single hydrogen atom will be there, that time we will get the mixture of products of aldehydes and ketones, right? So these are the preparations, or these are the reactions where we can obtain both aldehydes and ketones from the same reactant, right, and under the same condition.